Monte Carlo simulations are an ingenious way of combining many different probability distributions into one big one. It works like this. Find a probability distribution that matches the scenario you are trying to model. Take lots of random samples, record and plot the results. Using the results, we can generate probabilities for our own scenario. Just for one distribution, this is trivial. It's just Dr. Reese's first year stats. But when we have multiple scenarios with different distributions, MCS comes to the rescue. The use of the Monte Carlo method has been dated back to the 1930s. It was then pioneered by Stan Ulam, who altered the calculation for the likelihood of winning based on the cards dealt in the casino. Hence the simulation was named after the famous gambling district. It was then developed by the Manhattan Project scientists to produce the first atomic weapon. These scientists had very little access to uranium, and therefore turned to this type of simulation to calculate reliable probabilities. The Monte Carlo simulation can be used in a number of different fields, ranging from finance forecasting and project management to artificial intelligence for games. For all these applications, the simulation is used to predict the probability for future events. For instance, artificial intelligence in games uses a simulation to estimate the long-term impact of each move to determine the best move to make. The Monte Carlo method provides an unlimited capacity to model construction operations. This method is a relatively easy way to model different projects. It also provides a quick way to evaluate different combinations of methods, each with varying parameters. This technique gives the estimated time required to complete a project and may show that there are certain circumstances that have been overlooked in the planning stages. This is the case in larger projects, where including all circumstances may be difficult. This model is limited by computer capability, but more powerful computers cost more, and so the process can be expensive to run. It is also difficult to find correlations between all variables in a project. Techniques for assessing which distribution applies to a certain factor have not been fully developed. This method is designed to be used as a last resort when other analytical solutions are not available. The program evaluation and review technique is a method used to estimate the duration of projects. The value of the optimistic, most likely, and pessimistic times are used, instead of just a single duration time. This is the equation used, with the most likely time weighted higher than the other durations. This helps to shift time estimates away from more unrealistic limits. This will provide a more accurate method of performing critical path analysis. This simple manufacturing example shows a large batch production job with 3 tasks. Using a Monte Carlo simulation, we can calculate the probability of it being completed in a certain time period. For example, there is a 34% chance of completion in 14 months. In this example, we will use MCS to predict the mark for this video. This is achieved by constructing a table of all the criteria and the relevant values for the PERT method. Running the simulation a few hundred times with random input values, a histogram can be drawn representing the distribution of our possible total marks and showing the most likely result.